Question number 4.1. Consider f of x is equals to 2 divided by x minus 1. And that is a hyperbola graph. And then the first question, write down the equations of the asymptotes of f. So our equations of asymptotes, our value of q, in this case we have that, so that means our horizontal asymptote, we have the line y is equals to a -1. And then for our vertical asymptote, we will look at our denominator. We will have the line x is equals to 0. Okay, and then question number 4.1.2, determine the y-intercept of f. So to find the y-intercept of f, we'll let our x is equals to 0. And notice that in this case, we only have x in the denominator, and we cannot divide by just a 0. That whole expression will be undefined. So that means we do not have a y-intercept for this function. And looking at our previous question, we had our asymptote at the line x is equals to 0. And this is just the same as the y-axis. So therefore, we cannot have an intercept in the y-axis. So I can say here undefined. Y equals to, okay, y-axis. Yeah, y-axis is an asymptote, right? And then the third question, sketch f on a Cartesian plane, show all the intercepts with the axis and the asymptotes. Okay, now I can quickly draw my Cartesian plane there. Let's see, that's our y-axis. Let's give it a black pen. And then our x-axis, we have that. And then I'll draw my asymptote, my horizontal asymptote, which is the line y equals to a -1. Let's give that a black pen, no, a red pen. And then my vertical asymptote, it's the line x is equals to 0, which is just the y-axis. So on top of my y-axis, I put my asymptote. And then let me label this. We have the line x is equals to 0, and then y equals to a -1. And let us find our x-intercept for this function. So we will let y equals to 0, and then we solve for x. Right, and then I'll transpose the negative to the other side. I'll have 1 equals to 2 divided by x. Cross multiply everything by x. I'll have x is equals to 2. Therefore, there's an x-intercept at 2 and 0. So 1, 2. We'll say our 2 is there. And then since our a is positive, so obviously I'm expecting this function to be in my first and third quadrant. Therefore, the shape is like this, to infinity, and then my other curve to infinity, and there's no y-intercept, so we have that. And this is the function of f of x. That's 2 and 0. Question number 4.2. The diagram shows the graphs of g of x is equals to -2x squared plus 8. And f of x is equals to mx plus c. R and s are the x-intercept of g. Okay, and t is the y-intercept of g and f. T, there's our t. And then graph f intersects r and t, the straight line function r and t. Okay, now our questions. First question, Write down the range of g being our parabola. So where is our function of g defined for our y values? So notice that our function of g is defined starting from this point, this turning point, moving downwards up until negative infinity. So therefore, the y elements of g is when y is less than or equals to a positive 8. Well, I can rewrite this in interval notation and say from 8 up until negative infinity, 8 is included. And then the second question, write down the coordinates of r. The coordinates of r being the x-intercept of my straight line function and the parabola. So in this case, we'll use the midpoint theorem, right? Take a close look of our parabola. Our turning point is exactly on the y-axis. So meaning when we move from our origin here where x is equals to 0 up until that x-intercept, we've got 2 units. So similarly, when I move from x is equals to 0 here up until that x-intercept of the parabola, I should get 2 units. So that means, however, in this case I'm moving to the left, so that means here I'm supposed to have negative 2. Yeah, this is just the midpoint of a parabola, right? So that means that r, I therefore have negative 2 and 0. I just use the midpoint of a parabola. And then the last question, use the graphs to determine the values of x for which the function f of x is less than g of x. So where is the function f less than g? Observing this from left to right, the function of f, it's a straight line, right? Yeah, it's above g. F is above g here. And then at this point they're equal. And now f is below g, that's g. And then they're equal here. So that means between negative 2 and 0, the f function is below g. So I can present my solution as when x is greater than negative 2 and x is less than 0, or we can say negative 2 not included up until our x value 0 not included. Both solutions are correct, and that's our question number 4.